Okay, hello class. We're back for another day of videos here since I'm gone again, but bear with me, at least you've got something to go off of. So you should have your factor and remainder theorem notes out, and we're going to go through those notes today. So the very first thing on those notes says to list all of the factors of 24. So if you're making factors of 24, essentially you're looking at what multiplies to get to 24. So you've got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. If you want to list those factors, you tend to list them in order. So you would go 1, 2, 3, 4, and then work your way backwards, 6, 8, 12, and 24. So that would be my list of factors of 24. Now, the big question here is what makes these numbers factors of 24? And the answer to that is the fact that these numbers all divide evenly, or 24 divides evenly by all of these numbers. And that is with no remainder. Now, this is the idea that we're going to use going forward because we're going to be taking yesterday's lesson of synthetic division and putting it together with today's lesson of factor and remainder theorem and understanding that something is a factor of another thing if it divides evenly in with no remainder. So we talked about our remainders yesterday with synthetic division, so that's what we're going to be looking for. Okay, so let's take this idea into polynomials. So is x plus 3 a factor of f of x equals 2x cubed plus 11x squared plus 18x plus 9? So the question here is, does this divide evenly into this? Okay, now this right here, we know how to divide by this number. So all we're looking for is the remainder of 0. So if I'm going to divide by this, remember that the number that I'm putting in the front here is actually a negative 3. So we always put the opposite of it unless it gives us the solution. We're giving us that x equals, okay, in this case it would be a negative 3 if we're talking about a 0. Okay, so we're putting our 0 out here. And then you're going to put your coefficients in order. So we have a cubic, so we should have 4 numbers. So we're having a 2, the x to the second coefficient is 11, the x to the first coefficient is 18, and the x to the 0 coefficient is 9. And those are all in order. There's no zeros to fill in the gaps here. So we follow our synthetic division, a reminder from yesterday, bring down the 2, so that's a 2 here. 2 times negative 3 is negative 6. 11 minus 6 is 5. 5 times negative 3 is negative 15. 18 minus 15 or plus negative 15 is 3. 3 times negative 3 is negative 9. And 9 plus negative 9 is 0. And so that's all of our information there. Then you work your way backwards. Remember, I boxed this in because that's our remainder, which means, is this a factor of this? The answer is yes, because there is no remainder. And at this point, we don't have to do everything else with it back here. We just are paying attention to this last number. If this is a 0, then the answer is yes, it does, or it is a factor. It does divide into that because there's no remainder. Okay. To see that by graphing, we're going to pull out our graphing calculators. If you have your graphing calculator with you, obviously, again, it helps for you guys to look at them. But all you're doing here is you're going to graph the f of x function. Okay, so we're going to type in that function. Go ahead and do that now. Okay, so when you graph this function, it should look something like this. And the question is x plus 3 a factor of that? Well, if x plus 3 is a factor of that, we're looking for a 0 of negative 3. So I'm looking here, and it looks like this might be a 0 of negative 3. I'm going to check that out by analyzing the graph and checking for my zeros. So I can check my lower and upper, and negative 3 is in fact a 0 of that, which means that the answer is yes. So because of what you see here, because of this graph and negative 3 being a 0, the answer is yes to this. And again, that comes down to the graph that looked something like this. And this right here was the point negative 3, 0. So the answer is yes, because it's at an x-intercept there. Okay. The second question asks you, is x equals 2 a 0 of your f of x function? And this is a different f of x function here, but is x equals 2 a 0 of it? Now, this is already in the 0 format, so we're not doing a -2 when we do synthetic. We're putting a 2 out front here, and we're going to do our synthetic division. Okay, x to the third means I need 4 terms, so the x to the third has a coefficient of 1, x squared has a coefficient of 2, x to the first is -6, and x to the 0 is -9. So those are all of our numbers there. Follow synthetic division, bring down your 1, multiply, add those together, multiply, add those together, multiply, add those together, and that last number is your remainder. So the answer here, again, we don't have to go through and figure out what our leftovers are here. We go through and we just say the answer is no, because the remainder is not equal to 0. And so we do not have a 0 of the function with x equal to 2. To see that by graphing, again, head over to your graph. I'm just going to add in another page so you can see it separately. Go ahead and type in your function so that you guys know what you're looking at here. Look at your graph. So again, we're just checking for if x equals 2 is a 0, and it looks like that one is definitely not. If you're not sure, again, you can go through and you can analyze, find the 0 that's close to it. Clearly not a 0. It's close, but it's not a 0 of it. So we do not have a 0 in that spot. Again, what we're looking at there is we're looking at a graph that looks something like this, and this right here is not at 2. And so therefore, and that would be the only one that could possibly be there since both of these crossed at a negative point. But that gives you an idea. So that's why it's a no by graphing. You need to know how to do both of these by graphing and by using synthetic division so that you understand your two different opportunities there. Okay,